Okay, here this question they have given uh, uh, a diagram over here. So what they have mentioned in the question is the electron beam tube can be used to determine the specific charge uh, E over M ratio of an electron. A potential difference V is applied between the cathode and the anode to produce a beam of electrons. Right here we have parallel metal plates over here, and here we have a cube, and uh, here they say the beam is aimed at a fluorescent screen inside the tube, and the path of the electrons is seen on the screen. There are two parallel metal plates above and below the screen. A and B are connected to these plates and allow a potential difference to be applied across the plates. Explain why electrons are deflected into a parabolic path when a potential difference is applied between A and B. Right. Here, I hope you're familiar with the term parabolic, right? Why? Because when we are talking about projectiles in A's, right, we are talking about this path, right? The path. Uh, when we throw something like this, right? I hope you have done projectiles, right? The path is like this. We call that path what? A parabolic path, right? A parabolic path. Why it is moving along a parabolic path, right? The reason is we have an acceleration along the vertical axis, right? We call it gravitational acceleration. Or you can tell what the resultant force is acting along the vertical direction, vertically downward, right? But we don't consider the force, because when we are doing projectile motion calculation, we only consider the acceleration. But if there is acceleration, there should be a resultant force according to F equals ma, right? What about the horizontal direction? Horizontal direction, we have v cos theta. If it is v and this angle is theta, v cos theta. Throughout this journey, it is v cos theta. That is constant. Why it is constant? Because we don't have any acceleration or deceleration along the vertical axis, right? So the velocity of that object along the vertical axis is constant throughout the journey. So that's why it is moving along a parabolic path. So what are the conditions to move along a parabolic path? What? In the vertical direction, right? We should have a one. We should have an acceleration or resultant force, and in horizontal direction we shouldn't have an acceleration, and velocity should be constant throughout the journey. So uh, here the parabolic path can be taken in two ways. One is the electron beam can be moved towards this plate. If this is the positive one, right, the electron beam will move towards this way. Or right here it will be moved towards this plate if this is the positive plate, right? It doesn't matter, right? But when we are talking about projectiles, it is always uh, and the acceleration is always towards down, right? Because we all know the gravitational acceleration is always acting towards uh, uh, acting towards the center of our Earth, right? Okay, in this case, how can we write our answer uh, according to their question, right? First thing you have to mention, right, what uh, here if I suggest for the sake of argument, this is right. I'll take this one because you can easily imagine, because we already know about projectile motion, so I'm going to assume this is our electron beam and this is our positive plane. So each and every time when it is in between this what do you call fluorescent screen or these parallel metal plates, right? Here in between these parallel metal plate, not in the fluorescent screen, right? In between these parallel metal planes, it will experience a force, right, towards down. Why? Right? I hope you remember F equals EQ, because we have an electric field from positive to negative, right? Electric field in between uh, these parallel metal plates. So when electron is in between these parallel metal plates, it will experience a force. and its acceleration is always along the vertical direction. So what about the horizontal direction? The velocity of the electron beam is always constant along this horizontal direction. So I'm going to write this one, right? There is a resultant force there's a resultant force on the electrons along the vertical direction. Along the vertical direction, right? Okay, so what will happen to the electrons? They will accelerate along the vertical direction. So electrons accelerate vertically. What about in the horizontal direction, right? Have a constant speed or velocity. But in the horizontal direction, the electrons have a constant velocity or speed, right? Here, the next one, the potential difference V of 850 volts applied between cathode and anode show that the maximum speed of the electrons as they emerge from the anode is about okay, right? So here we have two parallel metal plates, and here's the electron. Suppose that electron is over there, right? So electron is over there, and it will accelerate throughout this uh, field, and we should have a field to accelerate that electron. Here we should have the negative one, and we should have the positive plate. Then what will happen? The field in between these parallel metal plates, or not the parallel metal plates, anode and cathode, right? The field itself will do work on this electron, right? The field is transferring this energy to the electron, right? How can we find that one? The work done by the field, is equal to V, W equals V Q. This is the work done by the field, right? So if we know the potential difference and if we know the charge, we can find the work done. So what will happen to this work done? This work done will converted into the kinetic energy of the electron when it is here, right? Kinetic energy of the electron when it is here. Got it? Right? Who's doing this work? The field, electric field, right? We all know if we keep an electron over here, here is our positive plate, then it will accelerate. Why it is accelerating? Because we have the positive plate over here and negative plate over here, and the field is from positive to negative, right? So electron will accelerate, right? Who's giving that? If it is accelerating, someone should give some energy, no? Otherwise it can't accelerate. Who's doing that work, right? The energy means work. Change in energy means work done, right? So who's doing that work? The field. So what we have to do is we have to find first what do you call work done is equal to 150 volts times the charge of an electron is 1.6 times, so 10 to the power minus 19 coulombs. And if you simplify this one, you will get this will be equal to right, this will be equal to the kinetic energy at the end, right? It is 1.36 times 10 to the power 16 joules, 10 to the power 16 joules, right? Now we have to calculate, they're asking so the maximum speed, right? So what will happen, the ek is equal to half mv square. So mv square, so what will happen to our v if you subject it, it is 2 times ek over m square root, then 2 times, right, 1.36 times 10 to the power 16 joules over, right, m. What is the mass of an electron? It is 9.11 times 10 to the power minus 31 kilogram, right? So if you simplify this one, what you will get here is, right, 1.73 times 10 to the power 7 meters per second. Here you need to put your answer in 3 significant figures, because here they have given it in 2 significant figures, right? Okay, in the second one, here they say the electric field strength between the parallel metal plates 1.7 times 10 to the power 4 volts per meter, right? They have given the length of the each plate, it is 7.5 centimeters. The electron pass through the region between the parallel metal plates. Calculate the vertical deflection of the electron beam. You should ignore the weight of the electrons, right? Here, right, when we are throwing something, as I explained you in the first question about by using the projectile motion, right? Suppose this is our two parallel metal plates, right, for the sake of argument I'm going to assume this is my positively charged one, right, and our electron will come from here. Electrons will come from here, let's assume, right here, and they will deflect like this, and we don't know that deflection. We are going to find that one, right? How can we find that deflection, right? Okay, it's very simple, right? All you need to is all you need is the knowledge about projectile motion, right? Why? I will tell you, right? Here will have some constant speed throughout this journey, and even along the horizontal axis, right? If we say it is u for the sake of argument, that will be u, and we don't want to calculate what this deflection, right? This deflection, right? Sy, I called it sy, and this is our what do you call sx, right? This is our sx, and we know it is 7.5 times 10 to the power minus 2 meters, right? Yeah, now I'm going to do my calculations, right? First thing I'm going to do, right, we know what is, we know s6, right, and we know u, we have calculated, then we can find the time it takes. How? Right, I'm going to apply s equals ut towards the along the horizontal direction, right? Why I'm doing this one? If I know t, right, when we are doing a projectile motion, right, if you know this t, then you can apply what, s equals ut plus half at square, right? Then you can find what, vertical deflection, or what which you call vertical displacement, right? So I'm going to calculate this one, right? Okay, here we want to find t is equal to s over u, right, s over u, and here it is, what is s is 7.5 times 10 to the power minus 2 meters, and over, what is the u, we have already calculated, it is 1.73 times 10 to the power 7 meters per second, right? Okay, if you calculate this one, what you will get for t is 4.34, right, 4.34 times 10 to the power minus 9 seconds, 9 seconds, right? Then here, right, I'm going to apply this equation, but we have a problem. What is the problem, right? We don't know our acceleration, right? 9 seconds, we don't know our acceleration. Here in this equation, we don't know our acceleration. When we are doing projectile motion, it's 9.81, but here it is not 9.81, right? We have to calculate. How can we calculate that one, right? I hope you remember that equation, what, f equals eq, right? By using this equation I can calculate the force. If I know the force, right, if I know the force, right, ma is equal to F or EQ. So what I can do here is I can calculate the acceleration, right? I'm going to calculate that one, right? Force is equal to what? Electric field, here they have given field strength 1.7 times 10 to the power 4 volts per meter times the charge of an electron 1.6 times 10 to the power minus 19 coulombs. So if you calculate this one, I'm going to erase this one, right? If you calculate this one, what you will get here is, for the force, it is 2.72 is 2.72 times 10 to the power 5 minus 15 newtons. This is the force. Now you should calculate the acceleration. Right? And you know the acceleration is equal to F over m. This is the resultant force acting on the electron, right? It is 2.72 times 10 to the power minus 15 newtons over the mass. It is 9.11 times 10 to the power minus 31 kilograms. So if you calculate this one, you will get 2.99 times 10 to the power 15 meters per square second as your acceleration. So now I can apply my equation. Here I don't need to worry about this ut because it is 0. The reason is we don't have any velocity or speed along the horizontal direction, or the horizontal, sorry, vertical direction. So my this is equal to, right, directly half at square. So half, and I know now a, it is 2.99, right? Here it is 2.99, right? 2.99 times 10 to the power 15 meters per square seconds times t square. T is 4.34 times 4. I will write over here, right? 4.34 times 10 to the power minus 9 second square. So if you simplify this one, what you will get here is 0.028 meters, right? 0.028 meters, right? Here in the next question, here they are asking the electric field between parallel metal plates is removed, right? The uniform magnetic field is applied to deflect the electron beam into a circular path of radius 3.5 centimeters. Assess whether this gives a value for E over m in agreement with the standard value. Here they have given the magnetic pulse, not the magnetic pulse, magnetic flux density, right? How can we calculate E over m ratio? By using this one, right? I hope you remember this equation. F equals bqv sine theta. If there's a charge, a moving charge inside a magnetic field, there will be a force, and we can find its magnitude by using bqv sine theta. And here you don't need to worry about what theta. The reason is what you call a magnetic field, and the v is perpendicular to each other. So angle theta will be 90 degrees. So sine 90 is 1. So I can directly use bqv, right? bqv, here it is sine 90, and you don't need to worry about the angle, and it is f equals bqv. So if it is moving along a circle, right, we all know, right, its force should be towards the center. We call it centripetal force, right? Its force should be towards center. We call it centripetal force, right? Here who's providing the centripetal force? Right? Magnetic force on the electron is provided that centripetal force. It means this PQV is providing that centripetal force because we don't have any other force. Centripetal force is resultant force acting towards its center, right? So uh, mv over r is equal to bqv. Why? Right? Because centripetal force, the magnetic force on the electron is provided our centripetal force, right? So I can cancel out 1v from here, and if I subject E over m from this equation, here I can write it like mv over r. We don't have 1v over here. Now it is not bq, here it is charge. Q means I'm going to write it as be. So E over m ratio will be what? E over m ratio will be v over rb. So if you calculate this one, E over m, here we already calculated v, right? We already calculated v. It is 1.73 times 1.73 times 10 to the power 7 meters per second over, right, rb, and r is, here they have given 3.5 centimeter, right? It is 3.5 times 10 to the power minus 2 meters, and b is, right, millitesla. Here it is 3 times 10 to the power minus 3 times Tesla. So if you calculate this E over m ratio, what you will get here is 1.65 times 1.65 times what? 10 to the power 11 coulombs per kilogram, right? This is our experimental value. So now I am going to calculate the original, or what you call not the original, theoretical, the real value, right? Here standard value, it is the charge of an electron is 1.6 times 10 to the power minus 19 coulombs, and its mass is 9.11 times 10 to the power minus 31 kilograms. So if you calculate this one, what you will get here is 1.76 times 10 to the power 11 coulombs per kilogram, right? This is the standard value and this is the experimental value, right? Then, right, you have to write your conclusion about this. What? The standard value, is little higher or greater than what? The experimental value. Experimental value. Here this is the standard value, right? The standard, this is the experimental, and we have write our conclusion. Yes, this would give us an accurate value. Yes, this give us an accurate, or here the give us an value in agreement with the standard value. Give us an a value in agreement with the standard value.